His theory is written in textbooks. His is the theory that is taught in British schools. His theory is called Out of Africa, and it revolutionised the discipline of human evolution. The creator of this theory is Professor Chris Stringer from the Natural History Museum. He joins iScience to give us a sneak preview of his upcoming Friends of Imperial College lecture. Let's start at the very beginning. Where did your fascination with human evolution begin?
Well, it probably began even at the age of 4 or 5. I was interested in fossils. I was collecting fossils from beaches and things. And I did a project on human evolution when I was 9 at school, sadly lost now. But yes, I was focusing on human evolution, and particularly even then Neanderthals and their relationship to us. So I was drawing skulls and things in my projects, and I think some people thought it was a bit strange, this kid always drawing skulls. But obviously I didn't think that would ever turn into a serious career.
And I believe this study eventually led you to develop your Out of Africa theory. How did you come to this conclusion?
Yes, well, so my PhD started in 1970, and I drove around Europe measuring all the Neanderthal and modern human skulls that I could get my hands on, because at that time the leading idea was that Neanderthals were our ancestors. So in Europe there should have been a kind of transition from the Neanderthals evolving into modern humans. So I was measuring these fossils and then using quite primitive kind of multivariate statistics to try and actually measure objectively, as far as one could, how different the skulls were, and were the Neanderthals really showing a closer approach to us through time. And the results I got were not supporting the idea of an evolutionary transition. The Neanderthals and modern humans seemed to be quite different from each other, consistently different, and through time they weren't getting closer to modern humans. If anything, in some ways they were getting more distinct. So we've got a replica here of a Neanderthal skull. This one's from France, about 50,000 years old, and I've got a modern human here. So this is just a representative modern human skull, and we can see there that there are clear differences. So both of them have got large brains. In fact, some Neanderthals have very large brains, even bigger than the modern average, but the skull is differently shaped. So if we just look at the Neanderthal one in particular, my measurements showed that the Neanderthal skull was longer and lower. Obviously this strong brow ridge over the eyes, a big face that was projecting, and cheekbones that were swept back either side. So this very distinctive face really, for me, marked off the evolution of the Neanderthals through time, not something we find in modern humans. And if we had the lower jaw, we'd see that there's no chin, which is a primitive feature. So ancient humans don't have well-developed chins. So if we pick a modern human, my data showed that modern humans have a high and rounded skull, small brow ridges, quite a small face tucked under the brain case, and this well-developed chin on the lower jaw. I wasn't working on the rest of the skeleton, but if we compared the skeleton of Neanderthals and modern humans, we would see differences there too in the size and shape of various bones. So my view had been that modern humans evolved in Africa, and then maybe in the last 60,000 years modern humans came out of Africa, spread around the world, and replaced these other species, replaced the Neanderthals, replaced similar ancient forms that were still surviving in China and Java. And it looked to me that it was more or less a complete replacement. I never ruled out there could have been some interbreeding, but in my view it was insignificant in the big picture. But 2 or 3 years ago, data, much more complete data, was being obtained of the Neanderthals and of these other people called Denisovans from a cave in Siberia, where ancient DNA has been recovered from fossils from there. And what these data showed was that the Neanderthals and the Denisovans had not died out completely. They were physically extinct, but some of their DNA lives on in many modern humans.
So looking to the future, I gather you considered retiring a couple of years back, but since then you've written numerous journal papers and books and all sorts. So what's next for you? What's next in line?
Well, yes, it's been a great few years, and I'm glad that I've still been involved in the field when all these new data are emerging. And obviously I produced a book on modern human origins recently, which really re-engaged me with the whole debate. So for the future, well, obviously, I'm working with archaeologists in looking at sites where we are mapping, if you like, the spread of modern humans the interaction with Neanderthals, the question of how much they really overlapped. That's something we really don't know. Where did this interbreeding happen? How many times did it happen? So these sorts of questions now are ones we can move on to from the new data. So one of the things I'm hoping to do in collaboration with Genesis is to add our collections to this data that's being acquired on the Neanderthals.
So genetics is very much a big part of the future of...
Yeah, absolutely, and it will continue to be, but it won't tell us everything.